Welcome back. This is Unit 1, Section 5, Transformation of Functions, Video 3, Determining Even and Odd Functions. So we were speaking about reflecting things across axes. So even and odd functions, we can determine them by those rules. So an even function has, notice that if you plug in negative x for x, you will get the exact same thing. And what I mean is, let's investigate f of x equals x squared versus f of x equals x cubed. So now we're going to do our test for even on both of them. So instead of positive x, we're going to make it negative x. Okay, now I'm going to break it down really basic here. But if you guys know what's going on, or if you could do it in your head, that's totally fine. You don't have to show your work. So here, this becomes negative x times negative x. And what are two negatives multiplied together? They're going to be a positive. So that gives us the same equation. And it equals f of x, right? Now what about x cubed? Well, that's going to be negative x times negative x times negative x. We know that these first two will give us a positive x. So then x squared. So then we're going to get a negative x cubed. So notice that f of negative x equals negative x cubed, which does not equal our original f of x of just positive x cubed. So that means this function is even, this one is not. That is what is meant by even. Now if we were going to do the odds, let's have f of x equals x squared versus f of x equals x cubed. So now we're going to apply the test for odds. And notice that's a combination of a vertical and a horizontal reflection. So a reflection about the x and the y. So I'm going to go negative f negative x equals negative x squared. See how I just plugged everything sort of in? Which is going to give me for this one equals negative x cubed. Okay. Well, from my previous, when I checked for being even, I know that negative x cubed is just going to be, negative x squared is just going to be x squared. So that's going to give me negative x squared, which gives me negative x squared. So this one is not equal to our original function of x squared. Well, what about x cubed? Remember that negative x cubed, right here, is equal to negative x cubed. So we're going to have negative x cubed, which gives us x cubed. And notice that we get our original function, x cubed. So that means that x cubed is odd, but x squared is not. Let's see. Determining whether a function is even, odd, or neither. We'll do this, but I just want to do a side note here. Now, graphically, if you want to know what it means to be even, if you were looking at the graph, so we have the graph of x squared, which we know is even now. So what that means is if you flip it over this y-axis, you'll get you flipped it, you'll get the exact same thing. That's what that means. Now, the odd's a little more complicated because it is symmetric about the origin. So this is the graph of x cubed. We know it's odd. So what that means is that when we flip it the first time over the y, and then we flip it another time over the x, we get our original function. And these are originals. So that's that is what it means graphically to be even or odd. So is the function f of x equals x cubed plus 2x even, odd, or neither? And it is possible to be neither. A lot of functions, most functions are probably neither once you add transformations to them. Okay, so for even, we're going to do f of negative x the screen is really sensitive. So that's negative x cubed plus 2 times negative x. And that gives us, we know this equals negative x cubed. This is going to equal negative 2x. So does that equal f of x? No, it does not. So it is not even. So what about negative f of negative x? So that means you're going to negate. Now watch this. This is a cool trick. So you're going to pretty much subtract this value or multiply this value by negative 1. So that's going to be x cubed plus 2x. And does that equal our original function f of x? X cubed plus 2x? Yes, it does. So this is odd. One thing I'd like to point out is notice that these variables will come into play later, these powers. So is this function even, odd, or neither? I don't know. Let's try. So first we're going to go for even. Or negative s is what they're using. Okay. So notice, negative s multiplied together 4 times. That's an even number of times that it's multiplied together. So that means that my negative is going to go away. If we multiply anything an even number of times by itself, then there will be no negative. The same goes for x squared, because 2 is even. So what do we have here? Does this look like the original function? F of s? Yes, it does. It is. So it is even, which means we can stop. We don't have to go any further because it can't be even and odd, and it can't be even and neither. It can only be one. Okay. This next unit is rather large, so I'm going to go ahead and stop here. This video is very short, which is completely okay. It's a relatively simple topic. Make sure you know how to do it because I do have to test over it. And I will see you guys in the next video.